Hello guys, this is DCC. So today we are going to see about what is the purpose of a SolidWorks software. So for that, we are going to first see about the solid origin of the SolidWorks software. SolidWorks is a solid modeling software, or else it is called as a computer-aided designing software. Okay, it can be also used for computer-aided engineering analysis. It is published by Dassault Systems. Okay. SolidWorks Corporation was founded in December 1933. 1993. The initial release is on November 1st of 1995. In 1997, the Dassault system was best known for its CATIA CAD software. CATIA is another software published by Dassault system itself. Okay, they had a stable release until 2023. SolidWorks 2023 is the latest version, and also there is going to be a 2024 version by the end of this month. Okay, the next, why we are going to use SolidWorks, we are going to see it has efficient design, and the design validation of this software is very much profound, and the collaboration with the other team communication and for productivity will be very good. The interdisciplinary integration of the SolidWorks software is very much good. Okay, what do you mean by interdisciplinary integration? Means if we go for mechanical engineering, means we are having part design and also other designs. Okay, part design and assembly designs. For electrical, there is for also electricals there is PCB design. PCB designs means you all very well know. Printed circuit board design, we can also do that with SolidWorks software itself. Prototyping, cost reduction. The prototyping of any type of design. If we take part design for mechanical engineers and PCB design for electrical engineers, the prototype of the first model we are going to create before we go on for the full-fledged production is called a prototype model. Okay, that cost of production of prototype model is very much less when compared to other softwares. Visual communication means the realistic rendering and the animation of the design part we are going to get to the customers, give it to the customers, and then they will use that rendered models, and they will assess the models by visual representation, and then they will they will give okay for the production. Okay, that is called a visual communication. It is very much very good in realistic rendering. Okay, manufacturability. The manufacturability of those products which we are going to design is very much good. The documentation and the compliance. The documentation means if you are going to use another software as CAE software to design the to make the analysis, means we are and if we are using SolidWorks software for creating the CAD models, if we are going to transport that model from the SolidWorks to any of the modeling softwares, any of the analysis softwares like ANSYS and HyperMesh, we are going to use some specific IGS format or else part file format and step file format. So for that, in that formats we can easily change that. Innovation and iteration. Innovative designs can be created, and education and skill development means it can be used to educate the even the school people also can be educated by using this software for creating models. Industrial stabilization means the widely adopted and simplifying collaborations can be used. Okay. Standard parts can be created by using the default settings itself, and default commands itself we can create standard parts. Okay, and then what are the things we can do with what are the things the SolidWorks are capable of is which is given here. We can create 3D designs, parametric models we can create, and assembly designs also we can create. Okay, if we are creating 3D designs and parametric designs, means we are going to assemble that and create that into a fully designed assembly model. Okay, and 2D drawings can be generated using those designs. Simulation and analysis, we can even simulate the working of the all the components, and analysis can also be done here. Rendering and visualization. Rendering and visualization means already referred to that. Okay, realistic renderings can be easily made here, and also we can make sheet metal designs and electrical PCB designs. PCB means printed circuit board designs can be created. Collaboration means collaboration with the other department team members. Okay, collaboration with other departments like electrical department and inspection department, we can easily use the same model to collaborate with the other departments for their standards, and industrial standards they can be widely used for many industries such as automotive industry, aerospace and manufacturing industry. It is a very user friendly software. Okay, and there are three types of designs are there. One is the adaptive design, and then another one is development design and the new design. Adaptive design means we have already created another product. We have already created one product which we are having, and then adapting to that design we are creating another design based on the first design. Okay, that is called adaptive design. Development design means the purpose of development design is to make the component a bit whatever the things we need, we are going to improve that, like improving its capability, improving its weight, that is reducing its weight. Okay, and then improving the performance capability of the product using design. Okay, we can that is called we can do that. That is called the development design. And in new design, we are creating an entirely new design out of the blue and out of the component, that is called a new design. Next thing is these are all the sizes: the basic size, the theoretical data, the dimensions, rectangular and applications of tolerance can be used. The actual size of the manufacturing product can be easily found, and the product collection of parts. Example, lathe machine has a number of parts, right? So we can create the number of parts, and the parts is the collection of features. Okay, for a single product means collection of parts, and the parts means the collection of features like sketch based features and applied based features, application based features. And then we have come to the product development cycle, PDLC, product development or life cycle. Product life cycle, either we can call it product life cycle or else product development cycle. Here the first thing is what does the customer need and what is the requirement of the customer. Okay, based on that customer needs, we are creating the designs and we are analyzing the designs. Okay, analyzing the designs whichever the customer is satisfied with. Okay, if the customer is not satisfied with the design, means we are changing the design, and then going on to the analysis part. In the design process, we will be using the SolidWorks software. The analysis part also we will be using SolidWorks software, and then for drafting also we will be using SolidWorks software. After the drafting, 5M process will be implemented, and then it will be going into the manufacturing phase. And then after that, manufacturing, real life assembly will be done, and then the new product will be released in the market. And then why we call it as a cyclic process means after the launch of the new product, the product will hit the market, and then based on its performance, the customers will give feedback. Okay, that feedback will be utilized in the customer requirements and the customer needs again, and then the development design of that specific product, or else we are going to if we are going to create a new product, means that feedbacks from the customer will be utilized. So it is a cyclic process. Okay, then in the next thing we are going to concept related to CAD. What are all the concept? Design intention, the design intention to intention of the design, what is the design purpose, and the feature based modeling, and then sketch features and applied features will be used, and then the parametric design and then the parametric design will be used, and fully associative designs also will be used. Swift means SolidWorks Intelligent Feature Technologies, that is called Swift. Okay, some technologies, intelligent technologies will be used to create the products. And then there are some terms we have to learn about before entering into the SolidWorks software. That is the origin point. Okay, if we take a plane and then draw a sketch, means we have to know the origin of the sketch, and based on that origin we will be creating the sketches, and then in the 3D designs there will be three types of things, that is the vertex, which is the corner, and this is the edge, the line which is called the edge, and these four lines and the four corners will be forming the face of the 3D object. And there are three planes are there. Those three planes will be used to those are the basic planes, and those planes will be used to draw the drawings, and then based on that drawings we will be converting that 2D drawings into 3D models. Okay. And then there is sketch elements. For making a sketch on a plane, we have to use these types of things. Okay, on the origin we have to know, on the plane the dimensions of the sketch, which is driving and driven dimension. Driven dimension means we have already given the dimension, the same dimension we are going to give it again, means that is called a driven dimension. Okay, driving dimension is the basic dimension. And then sketch definition, there are fully defined sketch, underdefined sketch, and over defined sketch, and there is also relations. Relations means we will refer to it as constraints. Okay, the sketch definition, if it is called fully defined, means it will be black in color like this, and then underdefined means it will be like this, it will be in blue color. And then there is over defined sketch, that is over defined means it will be like this, yellow and blue color. We don't need these two things, underdefined and over defined are undesirable things, and the sketch we need is a fully defined sketch. Always we have to you have to design the things with fully defined sketches only. And then moving on to the next thing, we are going to see about the graphic as user interface. Okay, user interface means the what are all the things we are going to see on the SolidWorks software if you open it. Okay, this first thing, this is the menu bar. Those menus, file, edit, view, like those menus will be kept here. And then this is the standard toolbar, or else it will be called as the quick access toolbar. If we need quick save, means we are having the save here, and quick open and a new option will be there. And then this is the command manager. This is the command manager of feature command. Okay, this is the feature tab, and this is the command manager on the feature tab. Okay, if you go for sketch, means sketch tab means there will be the command manager of the sketch tab. Okay, and this is the search bar. What are the things we have, we are going to search, we can search there. We can even search the commands also there. Okay, this is the heads up view toolbar, that is the miscellaneous toolbars we will be always using, like this zoom things, and then section view, and then the views, top view, front view, and isometric views can be changed here. And this is the visual rendering, how we are going to render the 3D model. If you are going for only shaded with wireframe, and wireframe models and surface models, we can change it here. And this is the appearance, edit appearance option. We can edit the appearance as per our wish, and colors, whatever the colors we can give. Okay, this is the task plane. Okay, while moving on to the software, we will be discussing this about this one. This is the graphic area, and this is the model which we have just created, and this is the manage plane. This is the manage plane. What are all the managers? This is the feature manager design tree. Okay, if you go for assembly, means there will be assembly model tree. Okay, assembly manager design tree. Okay, we will be having. So what are all the how we are going to create this model, that will be enlisted here. First we have created using revolve option, and then we have used a chamfer option, and then cut extrude. Okay, like that each command we are going to give, it will be listed here. Okay, and this is the graphic user area, that are simply called as graphic area. This is the part where we are going to work all the components, and this is the status bar. What are all the things in the status will be provided here. So it is having IPS, that is inches, pounds, and seconds. This is the part we are editing that part. That's why it has a return editing part. Okay, and then the sketch entities we are going to see. So what are the sketch entities? Line, there is construction lines, horizontal lines, and vertical and angular lines. Okay, there is also center line, midpoint line, and circle, arcs, ellipse, rectangle, slot, and polygons are also there. Okay, these are all the sketch relations. There are two types of relations mainly. One is the relation for the geometric relations. It will be called as geometric constraints, and the relation by dimensions. That is simply called as the dimensional constraint. Dimensional constraint is nothing but the dimensions what we are going to give to the sketches, and based on that, based on the component, we are going to give that dimensions, and the vertical and horizontal things are the geometric constraints. That is the how the geometrically it is going to be set, all the sketches, how it is going to be set, it is called as the geometric relations. And then there is the SolidWorks feature toolbar. What are all the things on the features toolbar? What are all the things we are going to see? It will be explained here. Okay, in the extrude bar space, this is one of the most frequently used SolidWorks tool, which enables to convert the 2D sketch into 3D models. It helps to add the material to your sketch files. It is represented by this type of icon. And then we are having the revolved boss base, that is, instead of creating it by extrude option, we are creating the solid object with the we are converting the 2D object into 3D object by using revolve option. Okay, and there is something called as sweep boss base. Sweep boss base, it is the sweep feature which sweeps the closed profile through a open or closed path, making solid object. This feature helps to make the solid path by guiding through the definite path. Okay, if we are creating a path means, and on the starting of the path we are creating some rectangular or hexagonal or square sections, so it will be followed by the path, and the rectangular or square section will be followed by the path, and a path will be created. Loft boss base is it is also helps to add material between profiles of different directions to create object. Okay, suppose if you are creating an object starting like a hexagon and ending like a circle means, we can easily create that using lofted boss base option. Extruded cut is the extruded cut is the thing which is going to cut the extruded part. Okay, that is called it will be cutting and removing the 3D part based on the sketch. Okay, so for that we have to create the extrude boss base, or else any type of body we have to have. Okay, then only we can make the extrude cut. Okay, and then there is another thing called as revolved cut. By utilizing the same thing as a revolve option, we will be having the revolved cut option. And then there is fillet option, that is the fillet. It creates a round internal face by using edges of the solid model. Either we can use edges, or else we can create by using the faces itself. Rib option is the walled support to the solid body. You can also create do it using extrude boss base, but for saving the time, rib option is the best. Okay, linear pattern. If you want to create some object in a linear way, in an arranged manner, that for that we will be using the linear pattern. And then there is mirror option, there is wrap option, and shell option. All the commands will be discussed in the later video. Okay, all these commands will be taken in the later video when we enter into the software. Next thing, CAD in automobiles. In automobile industry, we can create like this. We can create the Audi R8 sports car model like this. Okay, and then there is the feature parts. 3D models of those parts can be easily created. And then these features will be consisting of sketch consist of geometry such as points, lines, arcs, and hyperbolas, and also splines. Okay, then there is surface modeling. For that surface modeling, we are first creating the surface. Surface is nothing but a zero thickness geometry, and that geometry we will be creating, and then we will be providing thickness to that geometry, and a solid model will be created. Some complicated models like turbine blades and car bodies, and then boat hulls can be easily created using this surface model, and then we will be adding the thickness to those components. Okay, and then sheet metal operations can be also done here. To gain the flexibility and quick and cost effective methods, many industries require a wide range of sheet metal parts in the to house the enclosed of the main products of their manufactured component. So for that we will be using sheet metal design to make the housing for the main components of the company. Okay, and then assembly is the thing where we are going to the parts we have created already will be put into the assembly model, and it will be assembled, and the simulation can be run also there. Okay, how we have assembled, based on that we can simply run the simulations also. Okay, there are two additional features in the SolidWorks software, that is standard mates. Standard mates is here we are having the part 1, part 2 and part 3. The part 1 is in red color we have changed and kept the part where on the top, and then in white color we have changed and kept the same part 1 on the bottom side, and in the middle part we will be having the part 2 as black color, and then the part 3 will be inserted here. So by using two of these parts, two of part 1, two numbers of part 1 and one number of part 2 and one number of part 3 can be used to assemble the this type of what you call this pokeball, right? Okay, we can create this, and then by using coincident, parallel and perpendicular, tangent, concentric and lock option, we can easily create this. These are all called the standard mates in a SolidWorks assembly software. Okay, this is the assembled model, and there is something called as mechanical mates. Mechanical mate means we are going to create some mechanically constrained some things. Okay, okay, this is the cam. This cam is going to rotate here, and this is the rocker arm, and rocker arm is going to oscillate here, and it will be pushing down this stem of the this valve. Okay, and then there is gear assembly. For cam we will be using this option, and this is the gear assembly. For gear assembly we will be using this option, and for rack and pinion mechanism, the gear has to rotate or else it has to oscillate. Okay, and then the pinion has to move like this. Okay, we can create the mates for using standard mates, and for these two gears we are going to use the rack and pinion option, and for hinge option there is directly a hinge option is there. Okay, and then there is a drawing option. Drawings can be created from parts or assemblies. We can either create by using simply the one part, or else the assembled parts in the assembly drawings can be converted into drawings, like the top view, front view and right side view and left side view, everything we can create. Also we can create isometric views and section views we can also create. In solid models, and nodes and dimensions will be added, and tolerances and GD&T, geometric and dimensional tolerances, can also be given there. And the drawing paper sizes can also be altered, and the 2D drawings can be fitted with their relevant information on the title box. Okay, and then there is a project for these gear arrangement. There are 4 gears arranged here, but we are going to only create only 3 gears, that is the internal gear, the 2 external gears, and this one external gear can be used as the same part as around here. Okay, the 2 of the parts are same, so we are going to only create 3 gears only. And then here is the nut and bolt model. For using nut and bolt model, we can simply use the screw option. Okay, screw option, we can use this and make the options mating these 2 options. Okay, this bolt and nut we are going to mate it by using screw option. Okay, and then there is project 2, the safety valve. The parts of the safety valve are given here, and we are going to assemble this like this. Okay, we can also simulate these options using simulation option. It is also available in SolidWorks software. So this is a 2D sketch of the assembled valve. We can create the section views like this. Okay, and that's it for today's session. Okay, and I have given some of the links in the description. Those links can be used to you can take this link and use it to um, create an opportunity for yourself and study the SolidWorks in a full manner. Okay, there is link for SolidWorks SolidWorks playlist, and there is also link for ePlan playlist, and we have created a full video course in Udemy also in SolidWorks and ePlan, and there is for also the oil and gas piping software course also we are having some videos and playlist. There will be a link provided in the description for that. So use this as the opportunity to learn more. Okay, and then if you have any doubts, means just ask me in the comments. Okay, please do share, like, share, and subscribe and comment. Okay, and also click the bell icon to notify whenever the videos come. Okay, thank you guys. This is DCC. Have a nice day.